Welcome everyone. In this walkthrough, we'll look at how to work out equilibrium amounts from initial amounts of substance in a chemical equilibrium. This is in the Year 1 AQA Chemistry A-level specification. We'll then go on to look at a calculation involving Kp from the Year 2 specification. Let's get started. Here's the first part of the question. 20.1 mole of carbon monoxide and 24.2 mole of hydrogen were placed in a sealed container. An equilibrium was established at 600 Kelvin. The equilibrium mixture contained 2.16 mole of methanol. Calculate the amount in moles of carbon monoxide and of hydrogen in the equilibrium mixture. We are given the initial amounts of each component in the question. At this stage, an equilibrium has not been established. There is no methanol present at the beginning. The forward reaction rate does not equal the reverse reaction rate. From the question, 2.16 moles of methanol are present at equilibrium. This is an increase of plus 2.16 moles. From the balanced equation, for each mole of methanol that is produced, 1 mole of carbon monoxide is used up. If 2.16 moles of methanol are produced, 2.16 moles of carbon monoxide are used up. For each mole of methanol that is produced, 2 moles of hydrogen are used up. If 2.16 moles of methanol are produced, 4.32 moles of hydrogen are used up. The amounts of each component at equilibrium are 17.9, 19.9 and 2.16 moles for CO, H2 and CH3OH respectively. Here's the next part of the question. A different mixture of carbon monoxide and hydrogen was allowed to reach equilibrium at 600 Kelvin. At equilibrium, the mixture contained 2.76 moles of carbon monoxide, 4.51 moles of hydrogen and 0.360 moles of methanol. The total pressure was 630 kilopascals. Calculate a value for the equilibrium constant, Kp, for this reaction at 600 Kelvin and state its units. The mole fraction of each substance is calculated by dividing the amount of that substance by the total amount of all the substances. You can check this by ensuring that the sum of the mole fractions equals 1. I have calculated the mole fractions here and quoted the results to 5 significant figures. Next, we calculate the partial pressures. The partial pressure of a component is given by its mole fraction multiplied by the total pressure. You can check if your partial pressures are correct by adding them up. The sum of the partial pressures is equal to the total pressure. Finally, we substitute the partial pressures into the Kp expression. There is one term on the top of the expression, there are 3 terms on the bottom, so the units of Kp are kilopascals to the power of -2. The data in the question was given to 3 significant figures, so I have given the answer to 3 significant figures. Thanks for watching, and I hope you found this video useful. Comments, questions and suggestions are always welcome. Take care and goodbye.